Hello, Springboard friends. Today we're doing lesson 20-1, Making Predictions. The learning targets we are covering today in our first probability lesson is to reason about the likelihood of winning a game based on a probability experiment. And we will also provide support for winning strategies of a game based on a probability experiment. So there's some vocabulary, obviously, that you need to know to better understand what the learning target is. Our first one is probability experiment, which is a repeatable procedure with a set of possible results. So when you think of experiment, or when I think of experiment, I think about something in science class, pouring liquids together to create a chemical reaction, but that's not what we're talking about here. We're talking about an experiment where we would flip a coin, spin a spinner, roll a dice, draw something out of a bag. Those are considered probability experiments. So we're looking at the chances of something happening. We also have the word predict or prediction, which is making a reasonable guess about something that will happen. So since we're going to kind of stick with the science theme here for a second, I would consider a prediction kind of like your hypothesis. But remember, a hypothesis is an educated guess, and hopefully we were also going to be making these predictions based on knowledge that we have from what we are going to be doing. All right, so let's start off with doing a first example. So if you get confused with any of the questions on your assignment for lesson 21 and 20-2, just go back to the video and you should be able to get the help that you need. All right, let's do our first example. It says Sebastian and Adrian are playing a game in which the player who spins the larger number is the winner. So question 1 says, Sebastian decides he will choose spinner A. Do you agree with Sebastian's choice? Explain why or why not. So Sebastian here is looking at spinner A. So I'm assuming when Sebastian is looking between A and B, he obviously wants the bigger number. So the bigger number here is 8. Well, if I look at the size of 8 here in spinner A and look at the size of 8 here in spinner B, I'm obviously probably going to want to go with spinner A, and knowing Sebastian, he'll probably want to go with spinner A as well. So Sebastian is correct. 8 is the larger number on the spinner, and the space for 8 on spinner A is larger than the space for 8 on spinner B. So that's our reasoning behind why we would choose A over B. All right, example 2. Explain whether the statement below is true or false. The spinner shown above will land on 2 the same number of times if both spinners are spun 20 times. So if we're looking here to create a possible prediction, we need to use the knowledge that we have on the spinners. So once again, looking at the number 2 here and looking at the number 2 here, we need to use what we see and what we know to see whether or not this prediction would be right. Well, I'm looking at spinner A and B, and they're already different sizes, number 1. Number 2, it also looks like the 2 space is so much bigger than it is in spinner A. So I would be a little concerned with that being equal for both spinners. So I would say this is false because the spaces for 2 are not the same size. Spinner B would land on 2 more often because the 2 is the larger size. That makes sense, and I agree with that. Question or example 3 says, list the possible outcomes for the spinner above as ordered pairs, with the first number being the result from spinner A and the second number being the result from spinner B. So the way I'm looking here is, well, I'm going to start with 2. If spinner A is constantly spinning a 2 first, it could land with a 2 or a 2. It could land with 2 or 4. It could land with 2 or 6, and it could land with 2 or 3. So as we continue doing that, I would grab my pen and write those out. So it would be 2, 2, 2, 4, 2, 6, and 2, 8. So that would be all of the ones when they start with 2. So if I was going to do the same thing with 4, I would go 4, 2, 4, 4, 4, 6, 4, 8. Starting again with 6, 6, 2, 6, 4, 6, 6, and 6, 8. And then if the first spinner was also, it would be 8, 2, 8, 4, 8, 6, 8, 8. I said comma a lot. So this is what we're saying by creating outcomes. So outcomes are answers. They're what are the results going to happen from this experiment. So remember what I said earlier, experiments in probability are more of the events that are happening. So we are using the spinner to get an outcome. So we're using 2 spinners here to get the outcome. So spinner A gave us a 2, and then spinner B could also give us a 2, and so forth and so on. So the combination between these 2 spinners here is 16 different outcomes for this particular problem. Okay, so if you remember, if you have any questions on your assignment, going back to these questions, you should be able to get any questions answered that you have. All right, let's move on to example 4. This is our last example in section 20-1. All right, so we have some more probability experiments here that are going to help us out and better understand what is going on. So example 4A says spin, quote unquote spin, both spinners to play Sebastian and Adrian's game. Remember, their mission is to be the player who spins the larger number. The person who has the larger number wins. We're going to complete the table with a W if spinner B wins. So remember, we are looking for the higher number. We're going to put an L if spinner A wins, and we're going to put a T if both spinners show the same number. So let's go ahead and do that. So remember what I just did in question 3 when we did it as ordered pairs? This is basically going to be the same thing, but now we're just kind of using alphabetical symbols to help us out instead of mathematical terminology. So if I spun a 2 on my first turn, and you, let's say you're playing against me, you spin a 2, well, this is one obviously where we're showing the same number. So neither one of us wins in that round. We put a T in the box. All right, once again, my spinner spins, I get a 2, you get a 4. Well, you got the bigger number, so spinner B wins, you get the W in that case. 2 and 6, you win again. 2 and 8, you win again. So this round is yours. All right, so if I'm spinning a 4 and you spin a 2, finally, I can get some wins there. So I get the L because spinner A won. And we have 4 and 4, so that's a T because we both got the same one. And here's you winning again and winning again. So if I spin again, I win with the bigger number. I also win with the bigger number because I had a 6 over your 4. 6 and 6, we tied there. And we have a 6 and an 8. You take that win. Again, last round here. I get an 8, you get a 2. I win. I have an 8. You have a 4. I win. We have an 8 and a 6. I still win. And then an 8 and an 8 ties us there together. So if you kind of look, there's a little bit of a pattern. I tried to color code it so you could see it. We have ties going straight down the middle diagonally, and we got me winning with the higher numbers over here and you winning with the higher numbers over here. So once again, that's just again showing us a visual representation of how to document information and data from our probability experiment. And then let's take a look here at example 4B. Once again, this is our final example for lesson 20-1. 4B says, based on the outcome of your spinners, Did Sebastian make the correct choice in example 1? Why or why not? So remember, in example 1, Sebastian told us that he's picking spinner A because he thinks that the numbers are equally sized and there's better chances than what's going on over here in spinner B. I personally think he made the right decision, and that is actually correct. Sebastian should have been correct in choosing A due to the larger space for spinner A on the number 8. So again, 8 is guaranteeing us to basically dominate right away, especially if we get 8, we know we win because we can't get any bigger than that, unless the other person gets an 8 as well. So that's what we're kind of looking at with that. Looking at size, because we're also looking at our chances. In lesson 21, we're going to be talking about the chances and kind of using percentages and figuring out, percentages and fractions, I should say, figuring out are our possibilities for creating and winning and things like that going to be better with certain probability experiments versus others. All right, friends, let's continue here with our next lesson in Springboard Lesson 20-2, Investigating Chance Processes. So our learning targets here in this lesson are to collect data about chance processes in frequency tables and lists. We're going to determine probabilities for outcomes in a probability experiment. And we're going to describe the results of an investigation and support the conclusion. So we have some academic vocabulary. I did keep probability experiment here in our academic vocabulary. Just want you to remember that that is a repeatable procedure with a set of possible results. So once again, our experiments that we're going to be doing would be flipping coins, spinning spinners, rolling dice, pulling something out of a bag, things like that. And then we're going to talk a little bit more today about what probability is. Probability is an outcome of a probability experiment that is used as a number in between 0 and 1 that tells you what fraction of the time you would expect the outcome to occur. So we go from 0 being impossible, never, ever, ever going to happen. There is a 0% chance to all the way up to 100, which is possible. It will happen. There's no ifs, ands, or buts about it. So let's take a look at this image real quick to kind of explain what I mean by probability. So let's take a look here at the probability scale. So as we look towards this right now, it's saying that the sun won't rise tomorrow. That's basically saying that that's impossible. We know that it will rise, so that is a 0% chance that that won't happen. All right, so the days of the week starting with a T. We have Tuesday and Thursday. So 2 out of the 7 days of the week are going to be starting with the letter T. So I would say anywhere between here and here. So this one they say unlikely is about 25%, but I would say anything between like 0 and 49 is rather unlikely. And then an even chance here is your baby being born a girl. So it's either going to be a girl or a boy. So we're at 50% here. And then what is the likelihood that you'll receive a text today? It's pretty likely. So once again, I kind of go based here on the scale of like 51 to 99 would be pretty likely. And people would be like, but miss, 99%, that's like almost 100. You're absolutely right. But there is still that 1% chance that it could not happen. And then we talk about a square having 4 right angles. That always happens, so that is 100%. So if we were to turn these percents into decimals, that's where they are referring to the between 0 and 1. So 25% as a decimal is 0.25 or 25 hundredths. 51% is 0.51 or 51 hundredths. So that's where we're talking about in between 0 and 1. All right, so that was just a little background knowledge there on the probability scale. Let's move on to our first situation. Probability is all about chances and the way things happen. and the percent and the likelihood of things happening. So we're going to be looking at a lot of these sort of probability experiments. So the rules of this game are the first player spins and then the second player spins. Seems easy enough. The second player wins if he or she lands on the number different from the number the first player spins. If he or she lands on the same number, the first player wins. So if I'm player 1 and you're player 2, my mission is that we always land on the same number, and your mission is for us to land on different numbers. So I'm taking a look here at my spinner. And as I think about probability, remember I said that the chances are 0 to 1 or 0% to 100%. But if I take 100 and cut it into 4, because there's 4 different numbers, every section is worth 25%. So if you, according to question 1, it says if your friend spins a 1, is it more likely that your spin will match your friend's, or is it more likely that your spin will not match your friend's? Well, once again, if we take a look at our chances here, there's a 25% chance that we will match, because there's a 25% chance on the number 1, but there's a 75% chance that we won't match. So the chances of you winning are way better than the chances of me winning. So if we take a look back at our probability scale, it's pretty unlikely that we'll match, because if you look here, I said unlikely is about 25%. And you're at 75, so this is like pretty likely. This is also probably around 75% there. So your chances are way better than my chances. So in this game, the chances are less likely to match your friend because there are 3 sections that will not match your friend and only 1 section that will match. So the question here is, this is not a fair game because there is not an equal chance for both players to win on each turn. So we do not like this. So I wouldn't want to play anymore because you have way better chances of winning every single time. All right, so now let's take a minute to create our own spinner using probability data that was given to us by our textbook. So P parentheses 1 stands for probability. So this P stands for the probability of number 1. Rolling a 1 or spinning a 1 or pulling out a 1, it doesn't matter as long as you realize that that is the probability of something happening. So let's go ahead, and what I'm going to observe here is that the denominator is 8. So I should probably want my spinner to be cut into eighths. So I do apologize if my drawing is really terrible. So I've cut it into quarters. So now I have 4, and I'm going to cut it this way. Now I have 6, and I'm going to cut it this way, and now I'm going to have 8. Okay? So I'm just erase that and erase this just to have some space. Okay? So I'm looking here at the probability of a 1 is 1/8. So that means 1 out of those 8 pieces is going to be the number 1. So I'm going to put that guy right here. So this section is the number 1. Okay, and then I'm going to look here. What is the probability of getting a 3? So it means 3 out of the 8 are going to be 3. So I'll go over here. This is a 3, and this is a 3, and this is a 3. Okay, so basically right now, if I were to just take my screen really quick, and I just cut this down the middle, half of this circle is already filled in. So 3 out of 4 are the number 3, and 1 is making that remaining half. Okay, and now we have the number 6. 6, the probability of getting a 6th is also 1/8. So I'm going to put a 6 right here. So remember, we're designing the spinner. So there's multiple ways you can do this. I could have put these 3s over here. It didn't really matter as long as we are representing the probability in the appropriate way. Okay, now I need to have the probability of the even numbers being a half. Well, I can't use 1 because that's not even. I can't use 3 and I can't use 5. So I have to put a 2 and a 4 somewhere. So remember, they can be any number. I mean, any place, but we need 2 and 4, and we can put 2 and 4 anywhere as long as half of the circle is even. So I'm just going to go 2, 4, and 4. And there we go. So 4 out of the 6, so if I'm sorry, 4 out of the 8 are even numbers, and 4 out of the 8, if you look over here, 4 out of the 8 there are odd numbers, so we can do that. We matched what it said, 3/8. If you want to kind of clean this up a little bit, instead of having all these lines, I'm just going to get rid of all these lines and sections. So I'm going to turn this into just the section 3. So this whole section here is 3. I'm going to get rid of all of this so it just kind of looks a little cleaner instead of all those lines everywhere. Turn this section into a 4. And there you have it. That's a spinner designed to meet the probability chances that were requested to us by our text. All right, and here is our last example here in the case of investigating chance processes. All right, it says determine the probability of spinning each outcome on the spinner below. So this one kind of looks like they did what I just did in my example, and they kind of cleaned it up. But to be honest, I think it should be cut in 1/8 so I can better kind of understand the sections. So I'm just going to cut everything up here, and I'm going to cut this one like that. So now I should have 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here's me just redesigning a little bit. So this is a 1, and this is a 1, and this is a 3, and this 3, and this 3. Okay, so now I can kind of see everything a little better, and I can keep it so that I have a consistent common denominator. So what are my chances here of getting a 1? Well, I have a 2 out of 8 chance. And a 2 out of 8 can be simplified to 1/4. All right, what are my chances here of getting a 2? My chances here of getting a 2, it looks like there's only 1 2 on the board, so 2, whoops. There's only 1 2, so 1 out of 8, and that can't be simplified anymore. What are my chances of a 3? 1, 2, 3. I have 3 out of 8. My chances of a 4, also 1 out of 8. And my chances of a 5, 1 out of 8. Now, if we're going to get technical and try to put it on the probability scale, I'm going to grab my calculator real quick just to kind of see. Well, I know in my head right away that a quarter is 0.25 or 25%. Okay, so if I take 1/8 and divide it, 1 divided by 8 is 0.125. 0.125, which is 12.5%. So all of this seems rather unlikely at the moment. 3 out of 8 would be 0.375. Whoops, 375, or 37.5%. It's growing here, but it's still not like getting us to higher percentages. And then 1/8, we were already told, 12.5%, and then 12.5%. So most of the chances of us getting a lot of these different numbers are unlikely. But again, you don't have to cut this up if you don't want to. I personally chose it just so I can have the common denominator that way. And it's more of a representation to me to be able to see how I'm going to break this down. Once again, the questions in your assignments are similar to the questions you just experienced here with me in the video. If you do need any help, please make sure to ask either Mrs. Cernick, Miss Angela, or myself for any of the probability questions that you have, but hopefully the video should help you out pretty much. Please remember to keep checking in with your teachers this week and make sure you're turning in your assignments. All right, guys, have a great day. You'll catch me in the next video on lesson 23 and 24.